Oh, come on. Okay, at least we're streaming. So something worked. I don't know what's wrong today. Let me fix that. So first, OBS was unable to connect to YouTube. And second, YouTube was about to cancel my stream for some reason. I got an error. I got an error here in the studio telling me that like this, it was unable to create a stream or something. Not sure what exactly happened. But now I think we're fine. If you can't see the stream or anything, let me know. Okay. So, we're almost done. We are almost done. We just need to do a few modifications. And last time, I really liked the idea of having a stepper motor here instead of a regular motor. But that's for a different day, I guess. We have two main things that we need to do today. First, connect these two together, and I think the way that I'm gonna do that is by using nuts and bolts. I thought about different approaches, and I mean the nuts and bolts is gonna be the most secure way to connect it, because if I'm gonna implement some sort of a snap lock in the plastic itself, where like similar to how this works, it snaps in place. But the problem with this, especially with 3D printed materials, is that it could wear off over time, and I'm not sure how secure it's gonna be. So our best option is to embed two nuts. We can do threaded inserts also. I'm not a big fan of that because it requires post-processing, and you need an soldering iron and all the VOCs that it will, the toxic fumes. So, John, is the stream working fine? I see you sending some messages. Okay, so it looks like the chat is already working. Yeah, the chat never stopped working. The chat was working. The issue was with the video. The video stream was not working. But now it's fixed. Oh, what is this? Okay, this is weird. Huh. What the hell is this? Interesting. Okay, so I guess we're gonna start today's video with some debugging. Motor holder. Is this pocket? Wait, let me hide everything else. We had this pocket. What was mirrored here? Oh, wait. Okay, this is that. And then we had this pad. Okay, this is the pad that we're looking at. Let me take a look at the sketch. Huh, no, that's not it. Okay, this one, sorry. Okay, what's wrong here? Show me the original pad. Okay, I think I know what's going on. Oh, even the chat stopped for you, but now it's working. Okay, that's weird. Okay. This is one of the things in FreeCAD that sucks. I will explain it in a bit. Just let me look at the general params. We had a tolerance. Okay, so I increased the tolerance from 0.2 to 0.4, and this is what happens. So to explain it, I'm gonna delete this for now, and this line, the white line, is supposed to be here, this side, not this side. It's supposed to be here. And what I did is I told FreeCAD that I want this line, which is basically the distance between this line and this line, because it's perpendicular. I told FreeCAD that I want this line to be the general dot tolerance. And then FreeCAD said, yeah, okay. So this is 0.4 mil. Everything is fine. And now I go to general and I change this to, let's say, 0.8. And sometimes what might happen is FreeCAD will get confused. Okay, you want it to be 0.8 millimeter away from this line, but in which direction? In this direction or in that direction? And sometimes it gets confused and then the model will be wrong. Now, one thing is that this does not happen with the vertical or the horizontal constraints. These are, I think they are called signed. So they have a positive and a negative direction. And this gets saved somewhere in the file. So FreeCAD will always know, okay, this is in the positive direction, this is in the negative direction. So it knows that. But for some reason with this, the distance between 2 points, it's not signed. So we're gonna have to deal with it for now until I figure out a better solution. And technically, I can figure out the horizontal distance. For example, from this point by doing some math equations. This is just a triangle with a right angle. We know that this is 0.4 or the tolerance, but how do we know this? That's the question. Anyways, I'm not gonna worry too much about it at the moment. I hope they fix it from their side. But now it should be. Let's see, moving part, bearing. Should be fine. Yeah, it is. Cool. Again, so I want to connect these two parts. And I think what I'm gonna do is there's gonna be a nut inside of this part, and then two nuts, and then we screw it from the bottom. But thinking about it now, this will not be the best solution because we're gonna print this part on this face, lying on the bed. So the strongest part is gonna be between this face and this face. This is not gonna be strong. So the optimal solution is to secure this to this this way. So we're gonna have a nut here, or a screw here and a screw here, and nuts in this. But can it support a nut? No. I mean, it's not a big deal. It's not a big deal because even though it's not the strongest part, this face, it's still strong enough to hold it in place. So in a lure turner there's not much force anyways, so I think we're fine. And I also have a bunch of nuts to measure, so we have accurate results. And they have the worst packaging ever. Okay. I think that this is an M3 nut. But let me measure it just to confirm. Yeah, 2.7 something. I'm probably measuring the threads, but yeah, that's an M3 nut. So an M3 nut is a hexagonal that is 5.45 mil between two edges. And I think we need to write this down. Still have chat problems, but stream is okay. Oh, interesting. When you say chat problems, you mean like you cannot send a message or what? But you are sending messages and they are appearing in the stream. I can see them. Not sure what's wrong today with YouTube. I'm gonna create a new spreadsheet. I'm gonna call it fasteners. And here we're gonna define the screw diameter. Because one thing is, I don't know if we're gonna use the same screw for everything, but I mean everything has the same thickness. And at the moment, this is the only part that requires screwing at the moment. So yeah, I think we only need one. Screw diameter is gonna be 3. And here I'm gonna do SD screw diameter input. This is gonna be equal to. Kamel is here. Hello Kamel, how are you? How's everything? Yeah, text is not sent. Interesting. So you cannot see the text that you send, but then you can see it in the video itself. That's very weird. So we're gonna go for a minimum screw diameter of 0.5 maybe. I mean, M1 is gonna be like the minimum, but we're gonna set it to 0.5. And let's call this screw diameter. And here we're gonna do the nut. It's not a diameter. What is it called? Let's call it width. It was 4.54. Let me just. I forget stuff. 5.4. Interesting, I got different result now. It's not symmetric. Oh my god, it's not symmetric. 4.42 on one side and 5.42 on one side and 5.45 on the other. I'm gonna call it 4.5. Nah, it's not going through sometimes, but now it looks so okay. So I think all is good. Great. Great. By the way, I was no, this is input, not width. Input. Why didn't I type diameter? I was looking at this, I think. By the way, I was printing a lure. I mean, it's Monday night CAD, not Friday night lure lab, but it just finished while I was starting the stream. Let's see. I think it looks good. The only issue I have with it is that the line where I pause the print and then insert some balls and resume it, there's a visible line. I think that's because of ABS material. And the thing with ABS, once you open the door of the printer, because this is an enclosed printer, that's how you print ABS. And once you open the door and some air gets inside, it's gonna cool the top layer, and then when you print on top of it, it's not gonna stick well. But I think it's fine. Looks strong. I made the lip thicker. Ooh, I'm not gonna be able to see. Probably I should switch to my camera. Yeah, that's the lure we made on Friday. That's how it looks without paint. I ordered an airbrush, so we're gonna do some cool painting. Yeah, it looks nice. I did print one before it, and spoiler alert, I tested it and it is amazing. You're gonna see the video soon. Let me switch back to manual focus. Okay, you're gonna see the video soon. And I caught something with it. I'm not gonna say more than that, but it works well. Not width. Okay, we're gonna call this not width, but what is the maximum value? What did I call it? NT input and W input. And the minimum value is 1. And we're gonna call this not width. And we need a tolerance now. The tolerance here is gonna be, we already have a tolerance in general, but this is gonna be like for the plastic parts. I want a tolerance that is specific for fasteners, and this is gonna be something like 0.2 or even smaller, like 0.15. And this is gonna be the T input. I'm using this now. It's a lot less confusing because what I was using is like the name and then input, like rail length input, and then this is rail length. And then when you're typing rail, you're gonna get 2 options. It's a bit confusing. So T input, and then this one is tolerance. This is less confusing. So we're gonna give this a minimum value of, I don't know, 0.02, just to avoid having zeros or negatives. And this is gonna be our tolerance. And oh, we want one more thing. Wait, where's the nut? Where did I put the nut? Oh, here it is. I want the depth or the height. It's 2.5. Exactly 2.5. Nice. So we're gonna call this the nut height. It's 2.5, and the alias is gonna be NH input. Also some validation, input validation. So NH input. And the value is the minimum value, I don't know, 1 also, or 0.5. And this is the nut height. Cool. Okay. So, how many nuts do we want here? Now we can do We can do this similar to what we did in the last video, where it would depend on the width, but I think we only need 2 nuts. What was the minimum width of this? I think it was in general. Width minimum was 50, and we still needed to take the motor into consideration, but I think, yeah, I don't think it's gonna be less than 50, so we can just give it a padding of like, I don't know, 5 mil from the edge, something like this. Let's see. So we want to work on the motor holder. Yeah, it's already active, and we want to embed 2 nuts in here. Now, one thing we also need to take into consideration is the length of the screw. So screw length, because screws usually they are, for example, M3, which means 3 mil, or M4, which means 4 mil. This is the diameter, and then next to that you're gonna get the length, like 10 mil, 15, 20, 25, stuff like these. So length, I wrote it wrong. Let's assume it's 10 for now, and then we'll see how to compensate for this, because I think the thickness is gonna be affected based on our screw. If we're using 15 mil screws, then it's not gonna work, because what is the thickness at the moment? It's 10. So yeah, we'll probably need to modify that. Definitely need to modify that. And what is this? What is the value here? Let me see. Part design. Let's measure the distance between this edge and this edge. It's 5.6. 5.6. Our nut height is 2.5. I think this is fine. This is fine. But yeah, the screw height is not fine at the moment. Anyways, let's leave it at 10. I think this is... Do we even have less than 10? Five, 6. Oh, we have 5. What? 5, 6 to 12. Interesting. 6 mil, 10 mil. Okay, so there is a 6 mil version of the M3. But the most common, I guess, that you can find anywhere are like 10, 12, 14, 16, and 20. There are longer. I have seen 30 mil and I think 35, but chat issues again. Interesting. I wonder if the issue is from my side or... Stream, excellent, stream is healthy. Maybe because I turned on the ultra low latency. Should have stick to low latency, but I can't change it. Not sure. Yeah. Anyways. Sorry for the chat issues. I don't know what to do to fix them, to be honest. So screw length is gonna be 10 because that's the most common. And screw length input. Let's set it to 6. So 6 is like the minimum, or 5. And this is gonna be our screw length. And this is important because we wanna create a hole for the screw to fit in. So there's gonna be a hole from the bottom all the way, not to the top, but at least it's gonna reach the nut and maybe a bit above it. And this is where I think it might be a problem here. We can leave the nut visible at the top. It's not gonna look very nice. So what is the distance here? Wait. The distance from this face to this face should be 10. Huh. We can definitely leave the nut visible at the top. I mean, it's not gonna look bad. It's not gonna look that bad. Nose. Yeah, let's do it like that. So now the origin, where is it? The origin is at the bottom. What do we have? We have one datum plane. No, we need to create a new datum plane. So we need to create sketch at this face, which is exactly 10 mil above, which is our thickness. So I'm gonna create a datum plane, attach it here, and in the Z direction, we need the general params dot thickness. Okay. Hide the origin, hide the plane. With it selected, I'm gonna create a sketch. And now we need to create the hexagons. Wait, what options do we have? Hexagon, heptagon? No, it's the hexagon. Okay. So, we need 2. And I'm gonna take this one and make them symmetric. Okay. And then this is gonna be horizontal. This is gonna make it so it cannot be rotated. And this is also gonna be horizontal. And we can take this edge, come on, this edge and this edge, and make them equal. So now we need to, so now these are mirrored. They are completely mirrored and they are equal. So we need to define the length here, which is our, oh no, the nut width. So the nut width is gonna be the distance between this one and this one. And we can, you cannot set the distance between 2 lines. You have to select, so clear everything, select 2 points, and now you can do the distance. And this is gonna be our fasteners nut width. Okay, 4.45 mil. Cool. And I think the only thing left to do, so this will define the hexagon. It's completely defined now because the hexagon, it's inside a circle. So once we constrain the distance between these two, that's it. And we also made this vertical. So now you cannot rotate it anymore and you cannot scale it. So it's fully constrained. The only thing that is not constrained is the center. Where do we want to put it? And this is going to be a bit tricky. Let's see. So first we can center it inside horizontally. Let's center it horizontally. That's going to be easy. So the distance between the center and the center of the hexagon, or the origin and the center of the hexagon, is going to be, first of all, the thickness right here. So general dot thickness. So now we're here, and now we need to go not the full length of the rail, but half of it. So that's gonna be our motor holder params dot rail length divided by 2. And now we should be in the center. Cool. Cool. And regarding this distance, let's see, vertical distance. Do we have this width or this height? So we have the total width. Wait, let me see what parameters we have. I kind of forgot. Moving platform parameters. We only have the rail, motor holder parameters, rail, no. Rail depth, rail angle, the edge thickness, I think. Rail edge thickness. Let's see, it's set to 5. So let me close this. So distance between this and this should be 5. It's 11. How is this calculated exactly? Probably down here. Reset selection. So if I select this and this, yeah, 5 mil, clear everything. So the rail edge is this, not the one at the top, and then we have an angle, so we don't actually know this value here. Interesting. Very interesting. We can probably calculate it. We can calculate it. But for now, because that's gonna take some time. Because if you look at it, let's hide it. Wait. Okay. So this is what we have. So we know the distance between this point and this line. And we know the height here. And we know the angle of this line. So we can definitely calculate this. Good luck tonight. Hello Nikita, how are you? Thank you for the comment. Yeah, I'm definitely gonna need luck here. Nah, it's math. But I'm not gonna do the calculations, to be honest. I'm not gonna waste too much time on this. We're already 3 streams into this build. So for now, we're gonna assume, or we're gonna take a distance from the origin till up here. That is maybe a fraction of. Still good. I just came here to say hello. Well, hello to you too. I hope that everything is good with you. From my side, everything is good so far. And hopefully it will get even better. So we can take a fraction of the width. Maybe divided by 2. No, not divided by 2, because we're already at the center. So wait, where is this? We need to divide it by 4 to put it. Yeah. So this is gonna be half the distance between the origin and the top, basically. This will only be an issue if we increase this width, which is the rail edge thickness. If we increase this to a very big value, then it's gonna cause problems. I should probably add a maximum value. Let's do that. Let's give it a maximum value of 8, just to be sure. And yeah, I think the sketch is fully constrained. Yes, we can pocket it now. And how much do we want to pocket it? it's, oh wait, we forgot something. We forgot to add tolerance. So here we added the width of the nut, but this is gonna be a hole, so we need some clearance. And we have the tolerance here. We're gonna multiply by 2 because it's on 2 sides. And yeah. And now we can pocket it. And how much do we go down? This is the fasteners.nut height plus fasteners.tolerance. We only need 1 tolerance here. Cool. So we're gonna have 2 nuts right here. And now we basically need to create a hole. So we need to go back to that sketch or that datum plane that we have and create another sketch and redo this. So create a circle here and a circle here. Constrain, let's first make them symmetric to this line. Oh, wait. Point, line, symmetric. Okay, now it works. And we also need to make them equal. And we need to constrain the diameter to be fasteners.screw diameter. Now here, screw diameter. So the screw is gonna be 3 mil. We can probably add tolerance also. So, but you can leave it at 3 mil. And when you put the screw in, you can actually like screw it, force it in, and it's gonna cut the threads in the plastic. Yeah. But I don't think we need that because we're already using a steel nut, so there's definitely no need to do this. And again, we need to do the same here. So horizontal distance was general dot thickness plus the motor holder params dot rail length divided by 2. And then the vertical constraint, we set this to general dot width divided by 4. Cool. It's fully constrained. Now we can pocket this and select through all. Oh wait. Now we have a problem. And the problem is this will only cut this part because this is the selected part. So now I need to go to the base plate and can we get the sketch sub object shape binder? Yeah, we can. Cool. So we need to pocket this here. Sorry, I need to select the binder and then pocket and select through all. Click OK. Cool. Now we have this. So we should probably also add a hole here for the screw like to embed into, but I don't have any screws at the moment. I don't know what types of screw do I want to use because there are like the countersunk screw, and for those types you can basically do, wait, control click, you can basically do a chamfer like that. If you probably know what type of screw I'm talking about, but there are other types of screws where it's a cylinder, so I need to cut a cylinder. I think if I cut a cylinder I can support both of them, but I need the actual diameter, so let's set it here somewhere. Screw end diameter maybe. Let's call it 4.5 for now. We can change it. So this is SED input. And it's gonna be equal to maximum value of SED input and minimum value, set it to 1. No, not 1. The minimum value is gonna be the screw diameter plus 1. So it's always 1 mil, or the minimum value should be 1 mil bigger than the screw diameter. So if the screw is 3, then it's gonna be 4 here. So let's make it 4.5 for now. And this is gonna be the screw and diameter. And we also need the depth. So screw and depth, how much to cut? I don't know. 3 mil? Sorry. 3 mil. And this is SED. Oh, no, I already did SED. Screw and depth, SEDT. I don't know. The reason, again, I'm doing these abbreviations is because to avoid confusion later when I'm typing them in the formula editor. SEDT input, and the minimum value is gonna be 1. This doesn't matter too much. Screw and depth. And now we need to redo the sketch. We're gonna create a sketch on the XY plane. Look at it from the bottom. Cool. Again, 2 cylinders. They are symmetric. They are equal. One of them is fasteners dot screw and diameter, but we need to add a tolerance. So tolerance multiplied by 2. And now we need to center it. So the horizontal distance is going to be, this is tricky now, because now we're on this model, or this body. And as you can see, the other one started from here. This had a different, this has a different origin. And the difference between this origin and the other origin is it's 1 thickness and 1 tolerance away. So we used to go by thickness and then the rail length divided by 2. So now we need to go only the rail length divided by 2, but we need to remove this tolerance to be able to reach it. So let's see if it's gonna work. It will work. So not general, it's motor holder params dot rail length divided by 2 minus, we need to remove from it the tolerance, the general tolerance. And we should be dead center. Yeah, we are. Now for the height, first let me set this here. For the height, this is going to be the same. So general dot width divided by 4. That's it. And now we need to pocket this. If it doesn't show anything, then you need to reverse it in the other direction. It's trying to pocket outwards. And how much do we pocket? This is gonna be fasteners dot screw and depth. Now how much? not much material left here, but I think that's fine. Oh, we need a maximum value for this. Definitely need a maximum value for the screw and depth. The maximum value is gonna be the thickness, or no, not the thickness. Wait, before we actually do the formula. So the maximum value is the distance between, let me hide this, between basically this face and this face, which is this value right here. Now the thickness is all of this, but we need only this. So what is this? Let's go to base plate. We have thickness and then we have rail depth. So rail depth is the distance between this and this. So if we take the thickness and remove the rail depth, we get this value. And we can probably also save it here somewhere, but there's no need to do that. So in fasteners, the maximum value of this is going to be, we need to get this from base plate params dot thickness minus base plate params dot depth, and I want to leave at least 1.5 mil of material to hold the screw, or because if I don't leave this material, then the screw will just go pass through the object. So we need at least 1.5 mil of material to hold the screw in. So if I apply this, now it's 2.5. So we can't have a 3 mil screw here, or we will have to increase the thickness of our object. So if the screw that I have, for example, I measured it and it's the depth of the head is like 3 or 4 mil, then my only option is to make this part thicker, because it will not allow me to do so. Like if I set it to 5, nope, that's 2.5. Should probably add notes here. But that's fine for now. Oddlures, hello, how are you? 3 mil, okay. 2.5 is good. Where's FreeCAD? Oh my god, I'm looking for FreeCAD and I'm in it. What a day. Yes, so now we don't have to embed anything, because wait, where's the motor holder? Interesting. Yeah, so the nuts will be visible at the top. This will keep our part thin. Daniel K, what does this do? You mean the entire thing? This is a lure turner. I think I have one that I can show you. I forgot to publish my model. Interesting, I'll fix that in a bit. I updated this lure, by the way. I added another version. Where is it? Interesting. I added another version which has a 3 mil lip to make it stronger. If you prefer the thin lip, you can still have it. This is a lure turner. So when you make a fishing lure, and let's say you paint it and everything, you have to apply a clear coat on it so you can fish with it. If you don't do that, then water will, first of all, the paint will chip. And second of all, the water will go inside the lure and then it will no longer be buoyant and it's going to lose the action. So you need to apply a clear coat, which is, if you're doing epoxy, then you need a lure turner. It has to keep spinning. or the epoxy will just drip off of it. So you have to keep it spinning all the time. Yes, yeah, I'm gonna post it on Printables. So I already have one, but this is gonna be like an upgraded version. At the moment, I'm porting this from Fusion 360 to FreeCAD because now I have it parametric, so I can, whoops. For example, right now we're doing the screws and the nuts. Let's say I want to use an M4 screw instead of an M3. I can just change it here to 4 and it will automatically update. Everything can be modified. I can make it wider, taller, whatever I want. So that's step 1. Porting it to FreeCAD, making it parametric. Step 2 is going to be improving it in terms of electronics. Like I was using this motor. It's called, what was it called? Asynchronous motor or something like that. It's fine. It's completely fine, but it's a bit noisy and you don't have too much control over it. So I'm thinking of upgrading to a stepper motor like the one in 3D printers, and then I can have like a knob where you can make it faster, slower, you can control the speed and stuff like that. Is this working? My comments seem to fail. I got a similar comment from John. He's saying that there are issues in the chat. I'm not sure where these issues are coming from. Probably from YouTube, because I also had issues to start the stream. So when I was pressing start stream, it was giving me errors. I had to press it like 4 or 5 times. It wasn't working. I had to re-log into YouTube, refresh everything. Somehow it started to work, but I'm not sure what's wrong today with YouTube. Yeah. So what we're doing right now is figuring out a way to connect these parts after printing them. So at the moment, each one of these is its own part. So we have 1, 2, 3, and this part right here is not gonna be screwed in or anything. Because the idea is to make it possible to print, let's say, 5 of these or more than one and connect them together. And then you can also print, let's say, 4 or 5 of these parts, and these will slide on the rails. So you can, let's say, print 4 rails, attach them together somehow. We're going to figure this out. And then you can print 4 of these moving platforms, and they can move on the rails. We also need some sort of a spring mechanism where you can stretch the rail, put the lure in the middle, and let it go to hold it in place. And then you can do that for the rest of the lures, and one motor will spin all the lures. That's the goal, the end goal. So we'll see how that's gonna go. Yeah, so in terms of this, attaching this part to this part, we're done. That's all. We just have 2 nuts, 2 screws, and this should be super strong. Now we have 2 main things that we need to figure out: how to attach 2 platforms together, and how to make the spring mechanism. We can probably do 2 or 3 rubber bands. This should hold any lure. It's not gonna look that great though. We can do springs, we'll see. Or we can just do what I used to do, which is a screw. You unscrew it, move it, and then you screw it again to hold it in place. It's not super convenient, but it works. Now attaching 2 rails together. This is gonna be a tricky one because the rail is not that thick. I can go here and change the thickness to like 15. Let's see what's gonna happen. Hopefully it won't crash. Let me save before it crashes. Okay, everything is updated. No, something is wrong. What happened here? Let's debug this. Motor holder toggle. What happened here? This is the datum plane. Huh. What? How did... Oh, wait. Oh my god, sorry. Wait. The base plate has its own thickness. Oh, come on. What failed to recompute? Anyways, the base plate has its own thickness, which is this one. And now we have a bunch of errors. We'll figure them out, but let me see what happened here. I think I figured it out. It's this issue that happened on the last stream that I still don't know why it's happening, but if I delete this and then extrude it again, it works. Why? I don't know. I have no idea why. What was this one called? Moving platform params.rail length. Yeah, now it works. But yeah, so we increased the thickness and something happened here. Let's see what happened. Base plate. Okay. This is the binder issue again. No, we're about this. Okay. That's the issue. The issue is that we're using a different thickness. It's the base plate thickness. Okay. Now what do we do? Recompute? Okay. I got confused with the thicknesses. Good thing that we tried it. Let me save it. Yeah, so now it's thick. Is there a way to attach two together? We can probably have a hole here. We can have a hole and then something coming out from this side. And then the hole will fit inside of it. And then we can screw it from the bottom. But then the screw will go all the way up here because the distance is... Oh, come on. Selection 1 is this, selection 2 is that. It's 9 mil. So we need to add more constraints. So if we can make this from here to here at least, let's say 11 mil, maybe connect the bottom plates like puzzle parts. That would hold in one axis at least. I think all we need is one axis, you're right. We just need one axis and that's it. But then how do we attach this to this? No, that's gonna be a challenge. Gonna be a big challenge. No, unless... No, it doesn't have to. Because if the... Oh, come on. I hate navigation in FreeCAD. If the thing is coming out of here, and then here we have a hole, that's fine. This hole is gonna be covered anyways. Yeah, we can do that. We can do that. Now, how to do it parametrically? How to do it parametrically? So in the base plate selected, is it selected? No. Base plate, toggle active body. We can create a sketch here. So this is not the final thing, but just It's gonna be something like that, right? I don't want to deal with curves at the moment, but something like this. We can do fillets and stuff. And then, sorry. And then here, if I hide the motor holder, so now we're only looking at the base plate. It's gonna be the same shape, but it's cut out. And then these two will fit together like a puzzle. That's a great, it's a great suggestion. But then, yeah, then basically you need to place them on a straight table. So you need to rely on the levelness of the table. Not the levelness, it's fine if it's tilted, but I mean how straight it is. Which I think is fine for version 1. Okay, let's do that. So these are symmetric. These are also symmetric. We need to, interesting, this and this coincide. Always move stuff around to see if you have any loose ends. This will connect here. Cool. Now we need to oops, wrong. Yeah, we need to constrain it. And just to remember something, in the general, we had width, height, base plate length, thickness, tolerance. So the first pad we did is this. It was what? Base plate length. Okay, cool. This is what I'm looking for. Base plate length is basically the distance between this and this point and this point. Base plate length. We can do it by angle. We need a couple of parameters here. So going to the base plate, let's say connectors, and then connector. So what we need is this. So we can see better, I need to turn this on. So we need the length of this. And maybe we can constrain this in multiple ways. If we do the length of this and then the angle between this line and this line, then we only need the distance between this point and this point. Or, so it's like base length, distance, and angle. Or base length, end length, and distance. I think I'm not gonna do the angle because I want to stay away from these two. But I think with the angle I can do it also. Actually, I think angle is a better approach here. Yeah, I'm gonna go with the angle because these, they rely on the width. So if these two also rely on the width, wait, delete this. Let's do this first. I don't know why I'm off today. Okay, so we're gonna put this on this line. We need to constrain it somehow so that if we change the width, this does not get, does not cut basically these two. So let's start with connector. Connector. connector base width, and we need a connector end width. We need a connector length, and let's add a fillet. The fillet will basically be, oh come on, I keep forgetting. The fillet will basically be this here. Then the length doesn't make sense. This has to be vertical. This we can make it bigger. So let's take this point and the line. Or wait, we can do these and the line and make them symmetric. And then these two can be equal. This is like a fishing lure lip. Yeah. So this is gonna be our diameter around 20. Base plate params. So the width, we can make it equal to, again, we have to take into consideration the width, the entire width of the thing. So let's make it, for example, divided by 5, it's 20. Because the position of this rely on the width. This is 16, maybe even less. Something like this. And the end width doesn't make sense now, because we don't have 2 points. So I'm leaning more towards the angle. What's the angle here? The angle, it's about 125. Let's do the angle. So connector angle 125, and the length is basically the distance between this point and this point, about 30. And the fillet, set it to 20. So this is gonna be the base width as an alias. This is an input, so I'm gonna say CA input, connector angle input, and we need to validate the input. So it's going to be a max of CA input, and the minimum value 90. No, 90, we can't do 90. It's, let's say 95. And this is the connector angle. Connector length, so CL input. And let's give it a minimum of 15. And connector fillet. This is connector fillet. This is CF input. This is gonna be equal to max of CF input and the minimum value of 5. Cool. We probably need to move this here so we don't modify it by mistake. Connector base width. Okay, cool. Now we can apply the values. So this is going to be baseplate params dot connector. Oh, we still have a problem. Still have a problem because we need tolerance. So this is double N. Tolerance, we're gonna call it connector tolerance. I don't want to use the general tolerance because I need to experiment with which tolerance is better for this type of connection. So I'm gonna set it for now to 0.2 because this is like or maybe even 15, make it tighter. So this is the CT input. So now what I would probably do is start by, before I print the thing, just print this section here, the cutout, and then print the section that's gonna be here and try to fit them together and start modifying the tolerance. This one to see which one is better, which value is like the best. So connector tolerance. And this is gonna be tricky, especially with the angles. Let's see. The angle between this and this is the baseplate params dot connector angle. And this is gonna be baseplate params dot connector base width. By the way, how's the music? I'm not even listening. Is it like repeating? Sometimes yeah. Sometimes it doesn't. And the distance between this and this is connector length. And the radius here, connector fillet. Wait, fillet is too much. Why did I do it as 20? I probably measured the diameter. Okay, now it's fully constrained, but forgot to add the tolerance. Connector tolerance multiplied by 2. The angle is fine. The fillet, how do we do this? I think we just add 1 because it's a radius. So we add 1 tolerance. And now this is gonna be connector length plus baseplate params connector tolerance multiplied by 2. Is it multiplied by 2? I need to test this also. Is it multiplied by 2? Usually when I'm doing like, if I have a rectangle, it should fit in another rectangle. You need tolerance from this side and tolerance from this side. Yeah, it should be multiplied by 2. We can test this in a bit. We can duplicate this body this entire thing and move it here to see what's going on. So now I can just bucket it in the reverse direction and go through all. See how it looks with the motor holder in place. Yeah, it should be both sides. And I can probably make this bigger, this rail right here. But the thing is, the bigger I make it, the bigger I make it. Now thinking about it, maybe we can reverse this to the other side. Because the bigger I make this, the smaller the minimum distance between this one and this one is gonna be. And basically the smaller the support, the super small lures will not be supported. But there's gonna be stuff here anyways, like this one for example. So it's not that bad. And the motor here also, there's gonna be something similar to this attached to it. So I think we're fine. I can go to the motor holder params, change the rail length to like 35. And it's gonna cover it, so it's not gonna show up. Cool. And now we need to do the same on this side. So create a sketch here. Fillet. Another fillet. This, and this are gonna be symmetric, and these also gonna be symmetric. This one is gonna be the connector width or base width, and the angle here is going to be the connector angle, and this radius is going to be the fillet. And the distance is the length. Cool. Now this is fully constrained. We only have one constraint left. You can see it here. One constraint, which is basically the distance right here. And we already know that. It is called, whoops, base plate length. Close. And now we can pad it upwards. So how much do we pad it? Okay. Yeah, only till here. And this value is the base plate params dot thickness minus the base plate params dot depth of the rail. Cool. Yeah, I think it's gonna work. Now we can print as much as we want and stick them together. We can even glue them if we want it to be permanent. Cool. Motor holder, moving platform. Now let's try something. let's clone this. So I'm gonna save just temporarily, create a clone, and wait, I'm gonna hide these again. I keep showing them and hiding them. And I wanna move this by position on the x-axis minus, yeah, I'm gonna move it by minus general dot base plate length. Yeah, we need to move it. There's gonna be tolerance between these two in real life, so we need to also remove connector tolerance. Where is it? Yeah, that's not good. That is not correct. I mean, it's gonna work, but it is not mathematically correct. And that is because of the way I calculated this sketch. Where is it? This one. Plus tolerance multiplied by 2. The angle does not change. Here we added a tolerance to the fillet. And here we added 2 tolerances. I don't think that's how you offset a sketch in general. Now the radius offset is correct. This is, I'm sure of this. Here we have an angle, but no, it should work. Theoretically, it should work. Let's go back to this body. It's gonna be a tight fit. I guess max I can do is, but yeah, this is what when I was saying, should I do 1 tolerance or 2? What I was thinking about is in a rectangle, or in a usual, like if you have a circle or a rectangle or whatever, and you want to put it into another object, you are not constrained. It's a free object, and then you drop it into the hole. But here it's different because I don't know how to explain it. But you see this, where the two meet? Yeah, you cannot move this object, or you cannot compensate for the tolerance here. That's why it looks like that. Because in reality, if you want the tolerance to work as it should work, this should be plus baseplate params.tolerance divided by 2. Now, we're gonna have exactly 0.15 mil on all sides, but look what happened here. It's overlapping. So I think what we can do is we can cut from it to fix that issue. And then it will, I mean, the calculations will be spot on. It will be perfect. So we can go 0.15 this way, which is our tolerance, and then cut a line upwards. let's try that. So in our object here, we're gonna create a sketch on this plane. It's gonna be tricky. We already know where this point is, right? So horizontally, this is baseplate params dot, no, it's general params dot baseplate length. Now vertically, this is going, whoops, what happened? This point and this point. Vertically, it's going to be the baseplate params dot connector base width divided by 2. And now this is going to be our tolerance. I know this is an over optimization, but that's what I do. Now here, should we cut a tolerance or more? I think more, but let's try. We can control this later. I believe that it's more. I want to go up. All the way here. And this distance is going to be general dot width divided by 2. This will give us half. Yeah, we can do that just to cover everything. And now the trick is how to not cut this. We already know the angle. We already know the angle. So the angle between this and this is 180 degrees minus the connector angle. And this is going to be, whoops, what happened? Let's go up here and do that. And we can constrain this. Make it, I don't know, like 2 mil or something. Now it's fully constrained. Now I can pocket this reversed through all, and then I can mirror it vertical sketch axis. I want to mirror it on this plane, which is the XZ plane. Okay, now let's grab this, copy it, delete this body, clone it again, and in the X we need to go by this amount. Okay, let's see it. Yeah, I told you, we need more. But overall, looking good. The reason we need more is if I measure distance from here to here, we're looking at 0.17, which is weird. 0.17. And the distance, let's reset selection, between this and this is how much? Where is it? 75 micrometer. So that's 0.075. So let's go back to that sketch. And right here where we had, I think we need to multiply it by 0.075, wait. Yeah, by 2. Now it's good. Now we have 0.15 on all sides, I think. No. What? Uh, 0.17. Can we measure? Wait. 0.23. What? Point 17. Where is this 0.17 coming from? Our tolerance is 0.15. I mean, I'm not gonna spend an hour trying to get every like single microsecond correct, but I'm definitely gonna look into this later off stream. But for now, at least I have a way to change this and test again. So yeah. I'm happy with this. I am happy with this at the moment. So now we can, now the only thing that's missing to make a functional part is, oh yeah, one more thing. I'm not super happy with this hole. So these bearing fit really well with this green part, but the bearing and the parts together, how do they fit in this? I don't know yet. I mean, it's gonna be a press fit, but will they stay in place? I don't think so. So this is not a very good design. I need to figure out a better design for this. I think the best way would be to split the screen part into 2, and then we can like screw them together somehow. If we do that, then let me hide the body. Then these 2 bearings, I can put something here in between that will prevent this object from sliding out in any direction. It will stay in place always. And this will help hold the lure in place. So far, I'm happy with this. Going forward, again, I'm gonna fix the issue I just described, and I wanna look into the possibility of attaching a stepper motor And then we can have an electronic box here. We can enclose this entire thing, maybe add a fan for cooling, add a switch to turn it on and off, and a knob to adjust the speed, and maybe, I don't know, we can go fancy with a display to display like the current RPM. But yeah, I will upload this file to Printables, but at the moment I will not upload the STLs because I'm not sure if it works. But what I will upload is the FreeCAD file. Now, unfortunately, it's gonna be for supporters only if they wanna experiment with this, play around with the settings and stuff. But usually I do not release the STLs until I'm sure that it works. I have a version of it working, I'm using it, everything is fine. Then I release the STLs and everyone can download them. But I will, of course, not release the FreeCAD files for free. The STLs will be free, so if you wait, you will get the free STLs. Or you can watch the 3 videos, the 3 live streams, and you can do it yourself for free. So yeah, you have the option to get free files. Same with lures, by the way. If you watch my live streams and follow through, you can make your own lures. You don't have to pay anything for me. But with lures in general, I think I'm releasing everything for free, with some exceptions. Yeah. So everything I've done in Friday Lure Lab so far, except for the Xander swim bait because I haven't tested it yet, is free. This Chubb swim bait, I worked so hard on it, so I made it as a paid model or available for my supporters. However, I might do some modifications to it to make it swim better. These fins, they affect the action a lot. They ruin the action, actually. If they are not symmetric, that's the problem. How to glue them in by hand and make sure that they are symmetric. It's super hard. But yeah, overall, I'm very happy with what we have at the moment. I want to look into this issue with the what is it called, binder. I don't know why this keeps breaking. I'm using binders in other places and they work fine. FreeCAD sometimes is very unpredictable. Yeah. I think that's it for today. It was a productive day. Last time we did only one thing, that green thing. But it was so annoying to get this to work. The spiral, I don't know why. I've done so many spirals in FreeCAD before. I made a more complex spiral and it worked fine. I don't know why this one decided to break. But we figured something out. Apparently, spirals in FreeCAD, when you're doing them, we need the cylinder to show you what I mean. But if the spiral will result in, let's say, 5.4 turns, then it will crash and it will not tell you why. I figured this out myself. That's the annoying thing. It does not tell you why. It like the program will not crash, but it will not show the spirals, or it will show half of them. And it's so annoying. And I finally figured out that they have to be like regular numbers without any decimals. So if I create here a new body, and let's create an additive cylinder. Okay, cool. Height. Let's make it 30, okay. And then we can move it on the x-axis just to show you. So if I create an additive helix, select this face. Interesting. Select the face, then create an additive helix, okay. Yeah, so you have multiple options. I was using the pitch. Pitch, turns, and angles. Okay, nothing is happening. I think we need to decrease this like 50. Oh, wait, my bad. Oh my god. We need to actually draw something here. So let's assume we're using this. Where is it now? Yeah. Now we can do an additive helix. Okay, cool. So pitch is the distance between basically this line and this line. So the distance between two turns. And height is how much do you want it to go up? So let's say, yeah, you see it's super slow because what it's doing in the background, when you give it a height and then you give it a pitch, it has to calculate based on the shape you provided. Now we provided a circle, which is a simple shape. Then it's easier for FreeCAD, but FreeCAD has to guess, given this shape that you provided, and how can we make it 3.8 millimeters away from each other, basically. So it's doing calculations on the side, and it's not doing that. It's not doing a great job at doing this. So if I set it to like 50, okay. What happened? Yeah, if I now set this to like 4, it's super slow. Interestingly enough, now it's working. 2.7. Also working. That's weird. Why didn't you work last time? Okay, so it's working probably because I gave it a circle. If I modify the sketch, and let's say I added a vertical line here that goes through this point, and then I trimmed, where is the trim tool? I trimmed this edge. Let's put it here somewhere. It still works. Fascinating. Fascinating. Last time it refused to work, no matter what I did, and then the only way to make it work was to change it to a height and turns. So I would give it a height, like let's say 30 or whatever, like 32. and then tell it to do 10 turns, for example. But if I do 10.5, it was breaking, and now it's working. Fascinating. Anyways, I'm ranting. We don't need that body anyway. This is the part, by the way, that was causing the issue. And I don't know why I created a new body when I could have just showed you the helix right here. Turns, it's currently set to this. Clear it. If I do 7.5, yeah, it was doing that. And if I now change it to 7, or what was it? This. It's not updating. I need to click OK. Now it works. Very weird. Anyways, that's all for today. Thank you for watching my stream. If you have any questions, you can add a comment on this video, or you can join our Discord server. We're doing some fun stuff there, and you get to see more frequent updates about what's going on, what new lures I'm making, and yeah, ask questions, as I said. Anyways, I hope you have a great day or night or morning, and see you in the next stream. Bye bye.